Many fabrics are available in the market today and the consumers are preferring for more variety. And so, fabrics in the market have come out with a number of varieties, with a number of colors, number of designs, and these are available for the apparel purpose for both men and women, and also they are available for the household purpose and also for the industrial purpose. There is one principal fiber that is called the polyester, and this polyester is a petroleum byproduct and which has been identified very early and which is next to nylon. And there was a scientific group from DuPont company led by Dr. W.H. Carruthers, and who have focused on long chain linear polymers, and they were successful in bringing up this particular polyester. But there are two scientists from Great Britain, J.R. Winfield and also J.T. Dixon, who had really focused on this material and then brought it successfully in commercial form in 1941, and they named it as sterling. And the same material has been introduced in American consumers and they called it as Dacron. So, whether it is available in the form of a polyester or Dacron in America or terling in Great Britain, three of them refers to a polyester, a very good fiber and very comfortable fiber for the mankind. TFPIA, that is the Textile Fiber Product Identification Act, defines polyester as a manufactured fiber in which the fiber forming substance is any long chain synthetic polymer composed of at least 85% by weight of an ester of a substituted aromatic carboxylic acid, including but not restricted to substituted terephthalic units. Polyester fiber is produced or manufactured in a very simple manner, that is by the reaction between a dihydric alcohol and also dicarboxylic acid, which will be melted and then come out through a spinneret, and you find that there is a fiber which hardens and seen in the form of a long chain polymer. And when you take the manufacturing process into consideration, the raw materials required for this is ethylene glycol and also dicarboxylic acid, and or otherwise you can call it as a dimethyl terephthalate also. So, these two chemicals are combined in a chemical factory and they are brought into the spinning mill, and these two chemicals are placed in big autoclaves and which are like a huge pressure cookers. That means that there you find the temperature and the pressure being controlled, and depending upon the time availability, and these two chemicals are made to react with each other, and then the polymer will be made over here. And you can find that the two chemicals, they do not react at lower temperatures, but only react at the higher temperature. So, your higher temperature and pressure are required in order to make them react, and then the ester is being formed, and it is polymerized at this point, and almost 80 to 100% polymerization takes place in the autoclave itself. And then from the autoclave, the solution or the whatever the chemical, the ester, the polymer is made to pass and in the form of a ribbon, and the ribbon, when it comes out, it hardens, and the ribbons from various autoclaves are collected and then they are chipped out. And sometimes when the spinning mill does not contain this kind of arrangement, then these chips are being transferred there, and then they start melting those things and making the polyester form. These chips can be stored at lower temperatures, and then when it is required to manufacture, these chips from various autoclaves are collected and then they are passed through a hopper, and wherein it mixes all the chips, and in order to ensure the uniformity, and then the chips are made to fall on a hot grade. On a hot grade, this melts because it is a thermoplastic polymer. All polymers, most of the synthetic polymers are all thermoplastic. That means that they are sensitive to heat. So, when more heat is exposed, and then you find that these polymers take up the solution form. So, the hot grid brings it in the form of a solution, and then the molten solution is made to pass into tanks, and before that it is being filtered to remove any foreign matter in that, and then the material is now vacuum treated. Sometimes there are air bubbles when you are passing it from one place to another, air bubbles will appear in between, and if air bubbles are present and it is going to interfere with the production of long polymers. That means that it will be broken at that particular point wherever the air bubbles are present. And so, the solution is vacuum treated to remove all the air bubbles and then made to pass through a spinneret. A spinneret is something like an American shape of American dollar, and it is something like a funnel, and it has some holes, and and from there the solution will be forced through this spinneret, and then you find that the fiber, the polymer that comes out through the holes will be solidified, and then it will be coming out in the form of a fiber. Whatever the filaments that are coming out from a one spinneret will be taken in the form of a one yarn, and then it will be wound on spools. And actually what happens is this, the polymer which is made now at this particular stage is not having that much strength, because the molecular chains are not parallel to the fiber axis. And so cold drawing is a process in order to improve the strength of the polyester. That is, it will be cold drawn. The filament that is coming out from the spinneret is taken and it is cold drawn 5 times its length. So when it happens, all the molecular chains will take up a parallel form, and they are parallel to the fiber axis, and which will improve its strength that is coming out in the fiber. And then the filaments are collected from here, and they are given slight twist, because the filaments are there throughout the length, and so very slight twist is required for this one, and so it is placed over the spools after giving a small twist. And the number of twists depends upon the intended end use for this polyester. If it is used for the apparels, maybe like ordinary apparel, it is given slight twist, but if it is made for georgette or chiffon or crepe, it is given higher twist. Or if it is used for the technical purpose or industrial purpose, what happens is that it requires more strength, and so more number of filaments are required. In that case, the spinneret will contain many number of holes, and so the polymer that comes out of these holes form only one yarn. The number of fibers or filaments within the yarn depends upon the intended end use. This is a very much preferred fiber in most of the blends. The polyester fiber which is used for the mixing or for blending, these filaments are made in the form of a staple fibers by cutting them. So in order to do so, the filaments from different these spinnerets are collected in the form of a big rope like, and it is called as a filament toe, and it is taken and it is being textured, because if you take the fiber and cut into smaller lengths, the fiber becomes very smooth and it is very difficult to blend it. And so what they do, they corrugate it, or by texturing, there is a process called texturizing, and in this the fibers are made in the form of a coiled or wavy like, and then it is being cut into staple fibers, and which is used for blending. This is simply the manufacturing process of the polyester fiber. And coming to the physical properties of this fiber, we have the strength. Polyester is made in different strengths. It is having very good strength like 3.5 to 9.5, we can change and use it. When it is blended with other fibers, maybe the strength is being controlled, because when it is mixed with other fiber, it should not cut away because it is very strong. And so what happens is control the strength, and maybe they produce this fiber with the strength that is required by that fiber. And otherwise, this fiber, when it is used for the technical textiles and also for the industrial materials, it is made at a very high strength like 9.5, it can go above. And when you compare with the nylon, polyester is not that strong, but you can make it a stronger fiber, because it is a manufactured fiber, you can control anything in this. And then when we take the elasticity is in consideration. Now, when we call it as elasticity, then it has two things. One is elongation and the other one is elastic recovery. We can say that polyester has both good elongation and also good elastic recovery. But the recovery is being controlled by the stress. If the low stress is present, yes, it has, say for example, for 2% stress, it will be recovering around 97%. But if the stress is going higher and higher, maybe the recovery becomes little less. Thus, you can say that it has excellent recovery when compared to the mostly this cotton and other fibers which are mainly used for the apparel purpose. And maybe this is one of the important properties the consumers use this one, because it will contribute to the wrinkle recovery also later. And then resiliency. It has a very excellent resiliency. That means that when you take it in your hand, the whole fabric, and then leave it, after some time if you leave it, it bounces back to its shape. That is very good, and it will contribute to resistance to wrinkle recovery. And so, the polyester is having very good elasticity as well as the resiliency. Then coming to one of the other physical properties is the absorbency. It is very, very important. All of us know that the sweat that comes out from the body should be absorbed by the fabrics that we wear. Polyester is not very good in case of the absorbency. It is one of the hydrophobic fibers. That means it hates water, and so it does not take much water, and at normal ordinary conditions it will take up very less, but under standard conditions it will take 0.2 to 0.4% of moisture, but if it is 100% relative humidity also, it will take up only up below, I can say, just 1%. And so, when you take the absorbency into consideration, and then it is not very absorbent, but it has another quality that is called wicking. That means that it is capable of transferring the moisture. The moisture travels on the surface of the material, and so what happens is when the wearer sweats, the sweat that comes out, it will be transferred, it will be taken away from there, and it travels to other places, and thus it dissipates that particular material, and thus people feel comfortable by wearing this polyester. And so it is one of the bones for the polyester. Even though it is a hydrophobic fiber, it has a very good wickability which contributes to comfort of this property. Coming to other properties like abrasion resistance. Polyester is having very good abrasion resistance. That means that even if you rub it against some surface, it will keep up its shape and as well as its surface in a good way. Then the dimensional stability of the polyester is very good, because the fabric after it comes out, it is being given one of the finishes called heat setting. That means that it is set for its dimensions. Otherwise, what happens in cotton and other materials, when you wash it in water, then it shrinks, the fiber will shrink both the sides, longitudinal and horizontally, and it will shrink, and then you find that the material becomes smaller. So, that means that the fabrics are not dimensionally stable. But in case of polyester, what happens is, because of the heat setting finish given, and the fabric is set at a higher temperature, and thus that you find this fabric being highly stable. So, even if you wash it or if you do anything, and you can iron at a little temperature, nothing will happen to this material, and so the dimensional stability of this fabric is very good, and whereas this is not there in the other natural fibers. Drapability is one of the physical properties, and in which the fabric is made to drape. If the drapability is good, it can be used as a drapery material also. And then coming to thermal properties of the fiber, it is a thermoplastic fiber. It is little sensitive to heat, but it resists heat better than some of the polymers like polyethylene and all. And polyethylene and all, they will be melting at 150, but it takes around 238 to 290 degrees centigrade in order to melt it. Even ironing temperatures can be around 120, that means above the boiling temperatures, and so nothing happens to the polyester at that particular point. But it does not require also that much temperature, because it by itself a wrinkle recovery is there in this, and so we do not require to use it at a higher temperature for ironing and all. When you take the burning properties into consideration, when you take the fiber near the flame and it curls away from the flame, because it is thermoplastic, it is sensitive to heat, and when you take it into the flame, then you find that the fiber readily takes up the flame and it starts burning, and even after removal from the flame, you find that it keeps on burning. And after the flame is put off, you find that there is a small bead coming up on the tip of this particular fiber, and this, when you crush it, it becomes incrushable. You will not be able to crush it. Thermoplastic fibers all show this kind of thing, and so polyester, being one of the thermoplastic fibers, will have this particular quality. Coming to the chemical properties of these fibers, chemically you find that it is resistant to most of the mild alkalis that are being used for the care of the fabric, say detergents and soaps. They contain alkalis, but strong alkalis or concentrated alkalis at higher temperatures may disintegrate the polyester. That is one thing, and this is being taken as an advantage for finishing of some of these polyester materials. The surface of the polyester is being corrugated by use of these concentrated alkalis, and you find different varieties of polyester looking like just good silk. You find these materials, and so that is being taken as an advantage. But if you take the acid resistance, you find that this fiber resists mild organic as well as mineral acids at room temperature. But when you take the concentrated acids into consideration, concentrated acids at higher temperature may disintegrate this fiber, and so we have to be careful in using of these things. And it can be used for the mild acids and mild alkalis, no problem at all. And then coming to the bleaches, polyester is very good resistance for all bleaches, and nothing will happen to the material. And usually what happens is bleaching is not required for polyester, and sometimes these optical brightness are added to the spinning solution itself. So before it comes out of the spinneret, you find that the fiber is white, and so it does not require any more bleaching. It will be very nice, and also it will almost resist most of the solvents that are present. And for a daily use, whenever we are using the detergents, we are using some kind of materials in order to make it more freshen the fabrics and all. So for all these chemicals, nothing will happen to the polyester material. Then coming to the miscellaneous properties, electrical conductivity is one of the properties that is required in most of the fabrics, especially for the apparels. In case of polyester, because it is a hydrophobic fiber, it will not be able to do this particular thing, because the electricity that comes out, because when electricity will be produced by rubbing the fabric against another surface. So the electricity that comes up on the surface, if water is present, it dissipates into the atmosphere by drying it. But in case of polyester, it is not a hydrophilic fiber. So this will try to pile up on the surface, and thus the static electricity is being formed. And so this will be a problem in case of low humidity conditions, and a tickle sound comes out when you are taking out the fabric, and also it clings to the body, and it becomes a little problem in usage of this material. It is resistant to sunlight. The ultraviolet rays in the sun, damage usually the fabrics, but in case of this polyester, it is not damaged. And otherwise, I can say that it has a very good behind glass sunlight resistance. That means that when it is used as a drapery behind the glass, and it has a very good resistance, and it will not allow the UV also to come inside the room. And then coming to the microorganisms like mildew, is highly resistant to mildew, and also like moths and carpet beetles and the silverfish and all, it will be able to resist. Nothing will happen to the material. Even if you leave it in a damp condition for some time, no fungi will develop on these materials. But if you leave it for a long time, and if it contains something like a cotton or a rayon or some other fibers, maybe mildew may develop. Otherwise, on polyester itself, nothing will happen to the polyester fiber. And then one more thing is pilling. When it is cut and spun with other fiber, like when blends you find, then you may find there is a problem of pilling. That means that the fiber ends which are present on the surface, they entangle and form a bead like on the surface or knot like on the surface, and which are there on the fabric, and it becomes unsightly after using it. And so this becomes a problem in these materials. Otherwise, polyester having very good properties. When you take the perspiration into consideration, polyester has no effect with the perspiration, even alkaline perspiration or acidic perspiration. nothing will happen to the polyester material. Even the color on the polyester will not be changed with the perspiration, and so even it can be used as a blouse without any problem. Polyester fiber has many good properties and desirable properties to use it as a fiber for apparels and also for household or drapery, something like that, and also for industrial purpose and even healthcare fabrics also. The structure of the fiber is cylindrical and it is very smooth because it is a manufactured fiber and coming from the holes of the spinneret, and you find that the fiber is very smooth on its surface and it is just something like rod like. This fiber, it is very difficult to identify it even under the microscope because most of the manufactured fibers are rod like and they have the smooth surface. And also sometimes you find a pitted surface inside, that means that you can see small black spots within the fiber, and that shows the presence of titanium dioxide, because titanium dioxide is one chemical that is added, one pigment we can say otherwise. It is added to the spinning solution itself to make it a little duller, because when you have a shiny surface, when the light ray falls on it, it totally reflects, and so it becomes shiny, very shiny, and thus it may not be required for apparels. We don't like to wear fabrics which are very shiny all the times. Maybe at sometimes we may wear, but not all the time. So we need to control the luster or the the kind of brightness that is seen in the material. When you take the fiber, usually it is made in 12 to 15 microns, and also sometimes if microfibers are required, even if it is made 1.5 to 10 denier. And so these are the microfibers which are available for production of technical textiles. And so we need to have a microfibers which have a different properties when compared to the polyester fiber. Then when you come to the density of the fiber, we find that the density is little lighter, it is 1.38, and when compared to the cotton and all, which are having more than 1.5. And these fibers are used for making different types of clothing. Maybe it is a lightweight fabric or it may be a very heavy fabric also. It is possible to do with these materials. And then coming to the shapes of the fiber, you can find them sometimes when it is used as a functional material, and the circular cross section is no more present. It may be made in the form of a trilobal or in a T shape or a pentalobal or trilateral, or like that, the shape can be changed depending upon the end use for which it is being used. And then coming to the chemical composition of these fibers. If you take the chemical composition, then you find that you have an ester, and which is in the form of a linear polymer. And this linear polymer is having around 115 to 140 degrees of polymerization. So that means that 115 to 140 polymers are being chained together and in the form of a one polymer chain. And so several polymer chains are together in this particular fiber, and we have very important groups in this polyester. One is the carbonyl group, another one is methylene group, and also we have ester links, and most importantly benzene ring. So the stability of polyester fiber is because of the benzene ring. And even though there are not many hydrogen bonds that are present, because these are together, but this will not allow the hydrogen bonds to be made because of the low polarity of the oxygen, carbonyl oxygen, and also other hydrogen which is not that having a polarity. And so it is difficult to form the hydrogen bonds, but there are number of attractions because there are number of electrons that are present below and above the benzene ring, and these form very attractive bonds, and thus polyester fiber is very stable fiber for many chemical reactions and also for the normal usage. And then coming to the finishes that are being given to the polyester, you find that sometimes when it is blended and when it is in a spun form, then singeing is being done so that it removes all the the fiber ends on the surface and make it very smooth, and also it is calendered, and before that it is heat set. Heat setting is to set the dimensions, and singeing is to remove the fibers on the surface so that it becomes very smooth, and it is calendar to give again a smooth surface, and it is sometimes also given like embossing or schreinerizing, and there are many finishes that are being given to these materials in order to get some surface ornamentation. Like in case of embossing, you will get a raised effect, and it is passed between the two rollers. To one roller is having the engraved design, and at higher temperature, because the polyester is a thermoplastic one, it takes up the engraved shape, and thus it will be seen in the form of a design on the surface. And actually it is not the design that is being woven, it is the design that is being finished. And so like this, polyester may be finished in different ways. And also one more thing I think is antistatic finishes. In case of these polyesters, electrical conductivity is a problem, and in this electrical conductivity what happens is that it does not have good absorbency. Because of that, static electricity will be formed on the surface, because when you rub a fabric against any surface, electricity is being produced. And so when a fiber can absorb water, and it can dissipate the electricity into the atmosphere. But what happens, this fiber is not having that good absorbency, and so this will pile up all the electricity on the surface, and so it gives sometimes tickle sound when you are removing the fabric from the body. And if you do it without any light, you find that there are some sparks that are coming out. So that is because of the static electricity, and so it is not a very good conductor of this one. So after wearing, the consumer, for some time the consumer can take up a towel dipped in water and wrung, and then that can be taken over the material, so that the electricity will be being withdrawn from the fabric and he can wear it. So it clings to the wearer, and sometimes it is a difficult thing, especially in atmospheres where you have very low relative humidity. Soil repellency is another finish that is being given to polyester, because polyester has a problem with the oil. It absorbs oil so much, and so very difficult to remove the oil from the polyester material. One finish like soil repellency, it is given in order to improve its performance during the care of the fabric. That means that when the finish is given, it will not absorb the oil finishes that much, and it can easily be removed from this. And when you come to the consumer preferences, it is a versatile fabric, and there is easy care in this material. It is a very easy, durable and strong fiber, and also it is a wrinkle free material, and also there is a price advantage in these materials. Coming to the blending of these fabrics, whenever these fibers are blended with like wool is a very costly fiber, and so in order to bring in that kind of relative advantage to price advantage to this fabrics, usually the polyester is being mixed with other fibers like wool, especially for suitings. And when polyester is being added to that, it also helps in durability of the material, and also strength and other things will be taken care of by this material, because wool is highly absorbent, and this can be controlled to certain extent, so that the durability will be improved in wool. And in the same way, cotton, if it is blended, then you find that the fabric becomes very strong, very durable. And you can find these fabrics being used as a shirting material, and also mostly for the uniforms of the children, because maintenance is very easy and it is iron free. That means it can be worn without ironing for 3-4 times, and then it can be ironed. And so this is one of the reasons women garments today, they are made in polyester, and for draperies it can be used, and it can also be used even in health care garments, and as a bedsheet also, it is a blended material, but not in the operation theatres, and even it can be used for the tires, and it can be used for the belts, filters, and any other technical textiles and industrial purposes too.